This is a video for AQA Mechanics, Dimensional Analysis, Section 1.3, where we're looking at how we can determine indices in formulae that have been proposed for any particular situation. So we're going to be using the dimensions mass, length and time, and as an example of this, let's consider the following equation which has been proposed for the speed of a wave. If we look at it, we've got the speed is some constant k, and then we've got quantities density, acceleration due to gravity, and lambda, the wavelength. So those are all things which are quite feasible to be connected to the speed of a wave. The density, acceleration due to gravity, and the wavelength of the wave. But what we're trying to decide here is what powers we should have of those. So what are the values of alpha, beta, and gamma in this particular formula? Let's consider it a little bit more closely then. Well, we can determine quite easily the dimensions of each part of this equation. So the dimensions of velocity, well, velocity is a length divided by time, so Lt to the minus 1. Density rho is mass over volume, so we've got mass, length, volume to minus 3, so ml to minus 3, that's mass over volume. Acceleration due to gravity, acceleration is length t to minus 2. And lambda is a wavelength, so that is just length. So now if we look at our equation then, we can see that on the left hand side we've got the velocity, so the dimensions on the left hand side are Lt to the minus 1, and on the right hand side we've got rho, ml to minus 3 to some power alpha, got g, the acceleration, so Lt to the minus 2 to some power which is beta, and then finally a length to the power gamma. Well, you can see that on the left hand side we've got no value of mass at all, so that first part must have 0 power. So there's no m on the left hand side, therefore there can't be an m on the right hand side, so we can see first of all that alpha must be equal to 0. If we now compare length on the left hand side, we've got 1, and on the right hand side we've got beta plus gamma. And then comparing time, on the left hand side -1, and on the right hand side minus 2 beta and then plus 0 gamma. So we can see from those then that straight away the second one tells us that beta must be equal to a half, and if beta is equal to a half, then gamma must also be equal to 1/2. So just the idea of balancing the dimensions on both sides of the equation allows us to come up with a formula. So our formula in the end is that V is equal to K, and then we've got no value of rho, so we've just got G to the power half and lambda to the power half, or in other words we've got K root G lambda. So just stepping through this again, and nice and neatly now, there's our formula. Well, that's the end of this video looking at determining indices in formulae.